Hello friends, good evening. Welcome back to Domain Analytics program. And today we are looking into oil and gas data analytics. So yesterday we have seen the applications, right? So we have seen the applications of oil and gas data analytics, right? So in case of applications of oil and gas analytics, we have seen that we have the data that is related to oil and gas industry, and this data we are going to analyze, okay, during different processes. Like we have seen, we have drilling process. Okay, so we have a drilling process that we have in oil and gas data analytics. In the same way, we have seen that the market the market analysis that is related to oil and gas. Okay, what is the market? We have all these analysis that we have done based on the yesterday's analysis. In the same way, we are going to deal with downtime also. Okay, so what is downtime? So the machinery downtime that we have seen. So we when we are dealing with drilling processes, we will be dealing with heavy machinery. If there is any sort of maintenance issue, okay, so that may lead to downtime. Okay, so the production may be stopped here, right? So that will not be that is not, so that is not manageable situation. Okay, that is not a manageable situation where we can face the downtime, right? So all this data we are going to take and we are going to analyze this data, and this data belongs to oil and gas industries, right? So today we are going to look into how we are going to apply machine learning methodology. Okay, we have a machine learning methodology that is crisp mlq. Okay, this is nothing but the project management methodology, right? We have something called as this is a project management methodology. In this we have crisp mlq, right? So we know what is crisp mlq. Crisp mlq gives us the guidelines and gives us the procedures how to proceed with our project. So here we are looking into what is crisp mlq: cross industry standard process for machine learning, right? So with quality assurance, it comes with quality assurance. So what do we have today? So in today's agenda, we are going to discuss the different stages of analytics. Okay. The same way, what is the CRISP-ML-Q methodology, inferential statistics, unsupervised and supervised learning, data split, error, error functions, overfitting versus underfitting. So these are the different topics that we are going to cover in today's session. So what are the different stages of analytics? Okay, so these are different steps that we follow. Okay, and based on these different stages, we are going to achieve our goal. So what do we have here in case of descriptive analytics? When I'm saying descriptive analytics, we are trying to describe something. Okay, so we are looking into data. Okay, and here the question that we are asking is what happened in my data. Okay, so this is quite common in all analysis. Okay, which analysis could be, the data could be different, but the analysis could be the same. Like if I get some data that is related to oil and gas analysis. Okay, so what I'm trying to do, I am trying to find the trends in my data. So what are different trends in my data? So what are different patterns in my data? And I am going to plot these values. Okay. So we are going to use the graphical presentations when we are dealing with descriptive analytics. So we are going to report this data, right? Data reporting. So most of the companies, okay, most of the companies keep their most of their time for analyzing, for doing the descriptive analytics. Okay, this is very important stage in data analytics. So in the same way, because of diagnostic analytics, now we have found that there are certain trends that are taking place. Okay, like when we have, if you have some data in this way, when we are looking into oil prices and years. Okay, so every year what is happening? So we can see that there may be rise or fall in these values, right? So there could be multiple reasons for this. For these fluctuations, what we are seeing here, there could be multiple reasons, right? There may be a reason like inflation, right? There may be reason like war, right? Maybe climatic conditions, many reasons. The management changes in companies. So based on this, the production, the production or pricing, okay, if you take any values, there maybe we can see some fluctuations in data. These fluctuations are being observed in case of descriptive analytics. In case of diagnostic analytics, now the question is why? What caused these different fluctuations in my data? Right. So there will be something might have been happened here, right? Or is these fluctuations are regular? Or is these fluctuations are irregular? That we are going to find out. And here the question is why? Okay, why it is happening here? So by finding these details, now we have found what to have in my data, and now we have found why these fluctuations are happening in my data. Now the question is what I am going to do with this data. Right now, I have the trends and patterns that I have found. Using these trends, I am going to forecast my values. Right, I am going to predict the data in future. So I am going to use the values of prediction here. So in this stage of analysis, I am going to use my machine learning models, right? So I'm going to have these machine learning models and I'm going to do all my analysis and I'm going to predict some data. So what I'm going to do with these predictions, now I am going to prescribe something, right? Prescriptive analytics. Now I have some application here and I am going to describe something. Right? So these are four different stages of analytics we have. The first stage is descriptive analytics. The second stage is diagnostic analytics. The third stage is predictive analytics, and fourth stage is prescriptive analytics. So we have the specific methodology to pass through all these different stages here. Right. So what do we do? So the specific methodology that we have that is called as CRISP MLQ, Cross Industry Standard Process for Machine Learning Processes, and we use here quality assurance. Okay, it comes with quality assurance. Let us see how. Okay, so we have 6 different phases in CRISP MLQ, and the first stage is nothing but business and data understanding. And the second stage is data preparation. Third stage is model building and tuning. Fourth stage is model evaluation, and the fifth stage is deployment. The final stage that we have, that is monitoring and maintenance. So in case of oil and gas industries, we have to understand the business first. Okay, that means if I have a data that is related to some drilling process, so there might be like we may be having the well logs here. So well logs, this contains the different details about the depth of the well, okay, what is the formation of rock there, okay, and there are several other conditions. So we need to understand the business first, and we have to consider these different values and we have to work on it. So that is one thing. And apart from the business understanding, we have to look into the data understanding. Okay, so what is data understanding? So here we are going to work on different data types, right? So we have different data types. In the same way, we are going to work on data collection, from where we are getting the data. For example, in these cases, we can see that when it comes to, we have IoT sensors, right? So most of the oil and gas processors, they use IoT sensors. Okay, so we are going to get the real-time data. We are going to get the real-time data from these IoT sensors, which are fixed to the barrels. So we have IoT sensors that are fixed to the oil barrels. The same way, the IoT sensors are fixed to the logistics. So we are going to calculate the logistics. Okay, the transportation system that we are speaking about. Okay, so the vehicles will be fitted with these IoT sensors. And the wells, okay, when we are speaking of the wells, okay, in the wells also we have the sensors, okay, the sonic data and all we take from this wells. So apart from that, these companies will also have the historical data that is saved in database. So we are going to deal with this data for the further analysis. So now we have understood the business understanding process and data understanding process. Now, after understanding, we have the data. Now, what we have to do? We have to do the data pre-processing. Okay, that is nothing but data preparation. So, data preparation plays an important role here. Okay, that means our data may have different missing values. Okay, there may be a noise in the data. Okay, the same thing, same noise that we see in remaining domains. The same way, we may have the noise in oil and gas industry data also. Oil and gas industry data. Okay, so huge data we are going to get here. Okay, from the IoT sensors, every minute, every second, we are going to get some data. Okay, and it is a huge industry. Okay, it is a huge industry with a continuous processing that is happening. So we are going to get a huge data. So with the data preparation, we are going to model this data. Okay, model building here in this stage, we are going to select the machine learning model that suits my process. Okay, so we are going to select the machine learning model here. Here we are going to evaluate the model, and based on the evaluation, if I get the best evaluation and if I have the right fit, what I'm going to do, I am going to deploy this model. Okay, I am going to deploy this model, and monitoring and maintenance is the phase where if there is any change in my data, I am going to look into the deployment process for my perfect accuracies. So this is nothing but the crisp MLQ process what we have. So specifically when we are speaking about the oil and gas process, we have different processes that are going on. Okay, for example, we have evaluation of the subsurface geology, right? That means we are going to develop a tool for automatically mapping the characteristics of reservoir rock over an oil field. We have discussed yesterday, right? So what we have when we speak about the oil reservoir, it is compressed. Okay, it is compressed between different rocks. Okay, there is a earth crust, and we have all these material. Okay, the fossils that will be in this region, and it will be compressed by different temperatures and pressures, and ultimately this forms into a oil reserve. So we have a rock here. Okay, we have a rock here that will be present here. Okay, so we will be doing different analysis. Okay, so we are going to develop different tools for automatically mapping the characteristics of reservoir rock over an oil field. That is very important. So there are multiple approaches we have, like based on the data. Okay, based on the data, you can use interpolation techniques, non-gradient optimization techniques, gradient boosting we can use. Okay, so in the same way, we have, as I have explained earlier, we have well logs, a program for selecting geological data from well logs. That also we can do. Okay, so we use boosting. Okay, boosting technology. Okay, boosting the gradient by 100 times or more accelerates the process based on photos of rock samples that we get here. Okay, so this is also a type of data. Okay, we are speaking about different types of data that we get in oil and gas industries, right? In the same way, when it comes to drilling process, like here we are speaking about the evaluation of the subsurface geology. The subsurface geology is nothing but the earth crust of we are speaking about. So what type of rock is present here? All these details. Okay, based on the data that we get, we are going to do our analysis. We are also using the deep neural network analysis also in this case. So there are different analysis you can do based on the data that we have. Now, in case of drilling process, we have drilling process. What do we do here? We get the real-time drilling telemetry. Right? These are different sensors we are speaking about. Okay. This tool can detect the drilled rock form and possible failures. So what we are going to do with this data? We are going to build some machine learning algorithms in combination with deep neural networks, as well as we can use the gradient boosting also. There may be many other methods also. But the possible data that we are getting here is from the real-time drilling telemetry is the tool that we are going to use. And we are going to get the real-time data. When we analyze this data, we can detect the drilled rock form as well as the possible failures also we can analyze. So these are different use cases that we are seeing. In the same way, we can work on reservoir engineering also. What is this process? So traditional reservoir simulations can be speed up with these two. Okay, we are going to use some tools here based on the data that we are getting here. What we can do here, we can speed up. We can speed up the simulations that are associated with traditional reservoirs. Okay, we can use some techniques like deep neural networks also in this case. When it comes to product optimization, right? So when it comes to product optimization, a data-driven method for predicting the efficacy of well care campaigns. Okay, so we are going to deal with the different wells. Okay. So this is also very important. So we are going to get some data that is related to the production. Okay, so we are going to work on this data. So like gradient boosting plus feature selection, all these techniques are very important while we are working on these data types. So these are different tools from where we are going to get data. If we get the data, what are the different approaches? Okay, specifically here we're speaking about the AI approaches, AI related approaches. So machine learning plays a major role in oil and gas industries. So in case of data modeling, okay, data building, machine learning models. Okay, so we have the third phase, that is data mining. What do we do in data mining? So we find the trends and patterns in the data. Right? I am looking for trends and patterns in the data. So I have two different learnings. One is unsupervised learning and the other is supervised learning. So what happens in unsupervised learning? In case of unsupervised learning, I am going to have the data here. Okay, I am going to have the data here, but I do not have any output variable. So what we are going to see here, this is This is unlabeled data. Okay, this data is the unlabeled data. Okay. So in the same way, in case of supervised data, I have both input variables as well as output variables. This is known as labeled data. Okay, the output data is also known as label. Okay, target. Okay, that is the target value. We have multiple names for it. Okay, so the input data is the independent data and the output data is the dependent data. So here we have a flow chart where we can see that. So how we are going to train the data, how we are going to train the model if it is an unsupervised learning. So we are going to have the historical data. Okay, so we are going to feed this data into some machine learning model. So we are going to find some rules or patterns in this data, and based on the rules and patterns, we are going to do some analysis. So we are not going to have some output data now here. We are going to have only input data. So this data, okay, this data will be applied on new data. Okay, I'm going to take new data, and based, okay, the same rules and patterns will be applied on this new data, and we will be looking for the predicted outcome here. Okay, that is what happens in case of unsupervised learning. So we have supervised learning. Okay, as we have unsupervised learning, we have supervised learning here. So in case of supervised learning, so we do training and validation. We have training and validation steps here. Okay, so we train our model. Okay, I have selected a model and it is a supervised learning model. So what I'm going to do here, I have the historical data. Okay, from this historical data, I am going to have some random sampling here. Okay, some data. I'm going to take some data. I'm not going to take all population data. I'm going to take some data. And after taking this data, what I'm going to do, I am going to train my machine learning model. For training, I am not going to use the complete data what I have taken from the historical data. Okay, so now I am going to do my data split. Okay, in case of data split, right, usually based on the data, we do data splitting as training data set, validation data set, and testing data set. Okay, there are three different data sets we can take, and on training data set, we train our model. So we see that most of the data we take in training data set. So we feed this particular data set, okay, data set in my machine learning model. So in the same way, what happens here in case of machine learning model that I am applying here? Some mathematical equation will be applied, and based on this mathematical equation, I am going to do my predictions here. Okay. These predictions will be evaluated. How they are going to evaluate it? So how correctly I am going to predict if I have a y value. Okay, if I have a y value, y is my actual output. So now I am going to predict the same value. Okay, so y hat will be my predicted value. So are these values, okay, what is the difference between these values? Are these values same? Okay, whatever value I have, I am predicting this same value as my actual value, right? So is my predicted value and actual value same? So that we have to find out. Based on that, we are going to get either accuracy, or I am going to get either I'm going to get the error value, right? So here in this case, I am going to test my training data and I am going to evaluate it. I am going to get either an error value or I am going to get an accuracy value. So now what I'm going to do, I am going to apply my validation data on the same model. I am again going to I am going to do my evaluation, right? So I am going to compare these data. Okay, I am going to compare the evaluation values, and based on that, I am going to take a decision on my model. Okay, whether it is the right fit or not. If it is the right fit, if my model is a right fit, then I am going to take a new data and I am going to apply. I am going to apply the new data on my mathematical equation or my model. Okay, the right fit model that I have selected. Right? So what I'm going to get, I am going to get some prediction here. Okay. So this is the process that we follow in supervised learning. This is the flow chart that we can see here. So here we have discussed about the data split here, right? In case of data split, as I said, if this is my random data that I have taken, so I am going to divide this data into training, validation, and testing. Right? Three different factors that I have here. So I am going to divide my data into training, validation, testing, depending on the data. If I have more data, I'm going to take all these three different sets and I'm going to work on it. This will be my complete new data. I'm saying the testing data, that will be my new data. Okay. So based on this, we are going to work on different factors. Okay. So we are going to test on training data to get training error, right? So in the same way, we keep validating and keep retraining the model until desired accuracy will be achieved. How we are going to do this? We are going to change different models here. Okay, maybe we are going to change these different models and we are going to work on it. Or we may be changing the hyperparameter tuning. Okay, we are going to do hyperparameter tuning, and based on that also we are going to work on it. Okay, so when it comes to test validation, test on validation data to get validation error. So we are going to get these two values. Right? Either of these values, right? Error or accuracy or error or accuracy. So we are going to get the error or accuracy in my training data, error or accuracy in my validation data. So we are trying to compare this. Okay, and these using this data we are going to decide if my values, okay, if my model is correct fit or not. Okay. So here we have something called as error function. How to find if the value that you are getting, that is correct or not. What we are going to do here, first case, let us take the data as continuous data. Okay, like if I have the oil and industry data, what I have is like my output values are continuous values. I am taking price, okay, maybe $20, $30, $40, $50. Okay. So if I want to evaluate it, how I can do that? My actual value is Y. Okay, my predicted value is Y hat. For example, if I am predicting some students' marks, if like okay, if in 2022 I am predicting that, okay, maybe in 2023, based on the data I got in 22, I am predicting that oil barrel price will be $20 in 2023. Okay, but when we came to 2023, the actual value, okay, the actual value was $30. Okay, maybe in 22 Jan. Okay, in 22 Jan, I am predicting that my oil barrel price will be $20, but the actual value is $30. Okay, so what is happening here? So there is an error in my evaluation. Okay, error in my prediction. Sorry. So how I am going to find it? So this is my predicted value. This is my actual value. So my predicted value will be y hat and actual value y. So what I'm going to do? Y minus y hat gives me my error value. Okay, that is nothing but the error function that we call it as error function. Okay, so what we are going to do, we are going to take all these error values. For example, we are speaking about some data. Okay, so I have some data that is related to oil prices. Okay, so in the first I have some country name. In the second I have year. Okay, Third, I have company, some company, okay. And here I have oil prices. Now, what I'm trying to do here, I'm trying to, these are my actual values. So I have built some machine learning model, and what I'm trying to do is I am trying to predict these values. Okay. So maybe this is my actual data. This is my predicted values. Okay. So we represent this as y and y hat. So using this data, I have trained my model already using this existing data. What I have trained my model. Now I am trying to test it. Okay. So in case of training, I am saying that my values are like this: 21, 22. Maybe sometimes it may be like if it is less also 14. Okay, 30. So what we are trying to find here, we will be finding the error value here. Okay, we know how to find it. Y minus y hat gives me the error value. So what happens? I am going to get some value here. I am going to take an average mean value, and I am going to say that this is the error that I am going to get here. Okay, this is nothing but when we have the continuous data. Now the condition is if I have uh, if I have categorical values. Okay, if patient has cancer. Okay, cancer, no cancer. So now I am trying to predict this data. Okay, I have all data related to different patients here. Okay, each and every patient, I have the final output will be, we have to find either he has cancer or not. Now, what we are trying to find here, if I'm trying to predict here, so my prediction could be true or false. That we don't know, right? So here it is cancer. I am saying that no cancer. Here it is no cancer. I am saying that cancer, right? So we have all these values. So sometimes it is cancer. I am saying that yes, I am predicting correctly. It is no cancer. I am predicting no cancer. So what we are trying to find here, we are trying to find the comparison here equal to. Okay, if both values are same, my actual value and prediction value are same, that will be true, right? Condition I'm looking at. So in the same way, if my prediction is okay, if this is no, okay, it will be false, right? So this is what we are trying to find here. So the matrix that we take here to find these values is known as confusion matrix. Okay. So here we have taken an example. Okay, if my output variable is categorical, okay, here I have the actual class. Actual class is this is present or this is absent. There are only two different conditions existing here, and I have predicted class here. Okay, so now I am going to compare because when I am doing my analysis, I am going to get my predicted values after machine learning, after running my machine learning. Now I am trying to compare these two. How much of my prediction is true? Okay, now when I'm saying true positive, that means disease is present, so I have predicted as disease is present. This is true and positive. Okay, in the same way, uh, no disease, and I have predicted as no disease, right? This is true, negative. Okay, so these two values are very important that we can see here. So these are true predictions. We are concentrating on these values. If these values are more, my prediction is more. My accuracy will be obviously. Okay, here I am trying to look into accuracy, not error. I am trying to look into accuracy here. In the same way, we have false positive and false negative values. What are these? If I am predicting that this is present, but disease is not present. Okay, so in the same way, there is no disease, but I am predicting as disease present. So these are all positive and negative cases. Okay, so this is a false positive means uh, no disease, but I am saying that there is disease. Here in this case, disease is there, but I am saying that no disease. So these are few points that are very important when it comes to why is categorical. That means my output is categorical. I am going to measure the output. So how I am going to get the accuracy here? Accuracy is equal to true positive plus true negative. That is divided by all the values. True positive values, false negative values, false positive, true negative. Okay. So this is what we have here. And if I want to try the error value, we know what are the errors, right? So this is my error here. Okay, I'm going to add the error values divided by the total. Okay, so I'm going to get the accuracy in percentage. So how do we measure this? Okay, when I'm saying true positive here, the patient with disease is told that he or she has disease. Okay, that's correct, right? True positive. In the same way, true negative means patient with no disease is told that he or she does not have disease. Right? So these are two different factors that are very important in case of evaluation process. So we can see if I am just concentrating on true positive values. Okay, so I want to find if the disease is there, then I am predicting as if, there is a disease. Okay, so these value, okay, these value or these probability calculation is known as precision. They call it as precision. How do you calculate it? We take true positive values divided by true positive plus true false positive values. Okay. So the probability of correctly identifying a random patient with disease as having disease. When it comes to sensitivity, it is also called as recall or hit rate or true positive rate. Here we are completely looking into the actual positive values. Okay, true positive by actual positive. Okay, so what we are getting here, the proportion of people with disease who are correctly identified as having disease. So we are looking into different combinations. If I want to find only true positive values, okay, if I concentrate on true positive values and probability, the value that I am going to get is precision value. And in case of sensitivity, okay, so what I'm going to take, I am going to take the true positive value in combination with false negative. Because when I'm saying false negative, there are some values that are true also. Okay, these values should be here, but due to some error, these are here. Okay, we have something called specificity. Here we are completely concentrating on negative rate. Okay, so negative rate, and we are trying to calculate it. So in the same way, we can take the FP rate. Okay, this is the type 1 error that we see here. 1 minus specificity. So we calculate the specificity, that is divided by false negative rate. We have F1 ratio here. Okay, we take the F1 ratio, and that will be between 1 to 0. Okay, so these are few things that are very important when we are looking at confusion. So here we can see when I'm saying error, right? So error function, where we have taken the error function. We have seen that we are going to get some error and we are going to take the mean value. So what is happening here? So I have some data. Okay, I have taken some data. Actual data is 100 and forecasted data is 101. Now, how can I find this error value? 100 minus 101. Okay, when I do 100 minus 101, what happens here? Sorry, 101 minus 100. So I am going to get one value here. Okay, in the same way, 199 versus 200. What I'm going to get? I'm going to get minus 1 here. So by seeing these values, now what we have to do? We have to do this summation. That is nothing but mean error. I am going to take the mean error. When I do that, as I have the minus values, what is happening here? It is converted into 0. So can I say that my error is 0? Because I have some, I can see in my data that there is some error. So what I have to do? So we have come up with some solution that is known as mean absolute error deviation. So what we have done is like we have taken the absolute values here. What happens if you take absolute values? These values will be taken as one itself. Okay, the negative value will be nullified. Okay, so then in that case, what will be there? When I'm taking the means here, I'm going to add them, and so I'm going to get value. Great. So it's not nullified because of minus value. Now we have recovered. But here, in this case, we have again noticed that if this data has some value, some scale, kg, right? If the data has some scaling here, what happens here? If I take all the data, I am going to get something like kg square. Okay, if I have some value in this way, what happens? So to rectify this, okay, if I'm trying to square these values, okay, if I try to square these values, okay, so I'm going to get some value. Okay, whatever the data I'm trying to square this. That is nothing but mean squared error. In case of mean square error, there is a chance of getting scales will be changed. So in that case, what we have taken RMSE, root mean squared error. Right. So these are all different factors to measure your error value. Mostly we are going to take RMSE value. So on the overall, we have to understand that based on the error factor or based on the accuracy, we will be coming into one conclusion, that is right fit. Is my model is right fit or not? Okay. So what happens? Let us take an example. If my error, okay, like we have training data and we have test data. So what we are trying to do, we are trying to compare these two values with my accuracy or error values. Accuracy, error values. So I have got an accuracy of 90%. Okay, in training data, but I have got an accuracy of 75%. What is happening here? I can clearly see that my model is perfectly working on training data, but when I am feeding it with the new data, it is trying to, it is failing completely, right? But this doesn't fulfill our requirement because my model that I am creating, that should be generalized. It should be working on any other data, whatever data that is some related data I am giving here, right? So what is happening? This condition is called overfitting, right? And one more condition where my model is failing in the training only. Training only, I'm getting only 70%. What I'm going to do? I am not going to proceed with the further model. Okay, I'm not going to look into testing again. Here only my model is failed. So this condition is called as underfitting. Okay, the same thing we can see here. Overfitting is a statistical model that has been taken to be overfitted. Okay, so we are looking into overfitted condition when we train it with a lot of data. When we train it with a lot of data, there is a chance of overfitting. When a model gets trained with so much data, it starts learning from the noise also. And inaccurate data entries in our data set. Okay, so we are just dumping the whole data without treating. Okay, so we have a huge data, but there is some noise in data or some inaccurate data. What happens here? It takes these values also into consideration and it starts to learn. But in that condition, that leads to, okay, so this model does not categorize the data correctly. That is the problem. So we cannot predict perfectly. So my model will be doing good. Okay, it will be good when it is in training stage. But when I supply it with some test data, it fails. So that is something happens in both. So when it comes to underfitting, a statistical model or a machine learning algorithm where these underfitting condition occurs when it cannot capture the underlying trends or patterns in data. So it completely fails. It completely fails in the first stage itself. So it is so there may be some issue with my data. I don't know. Okay. So what I have to do? Maybe I have to concentrate on my data. Maybe I have to work on my feature engineering or my all these aspect data pre-processing. Or I can so after doing these changes, I can work on different. Okay. So these are different conditions that we have. Okay, these we have also when it comes to error function, okay, error function or accuracy measure, we are trying to evaluate the model. After evaluating, we are going to work on this. So we are trying to find if it is a correct fit or not. So yeah, when we say if there is high variance in metadata, okay, high variance in metadata, okay, it may lead to overfitting. Okay, so when it comes to the error value is high, okay, when the error is high, it may lead to underfitting. We can see here clearly, okay, there are two different techniques that we follow when we have the output variable in supervised learning. One is regression. Okay, in case of regression, my output value will be continuous. In case of classification, my output value will be categorical. Okay, so in case of regression, what happens? If I take this as my best fit line, okay, if I take this line as best fit line, I can see here that my data, okay, my line, whatever I'm taking here, so that is completely following this. Okay, so we can say that it is a overfitting, right? But in case of in this model, okay, these are different models. Okay, these are different models that we see here. Okay, the predictor too inflexible cannot capture the pattern, right? What is happening here? So I have some data here, but based on this, I can see the error values. When I calculate the error values, there will be error values. But in this case, what is happening? It is okay. It is following the same data. Right, my line is following the same data. So here I am having the less error. Right? The error will be less. Maybe in this condition, we can say that this is the right fit. But what happens when I get new data? Right? So there may be some issue. Okay, so this is something like overfitting condition. Right? My data performs very good in case of training process, but when it comes in new data, there may be some issue. So maybe here also we can see the same condition, right? So in case of classification, okay, I am trying to classify these models. I can see here, I have drawn a line here, but still there is some error I can see. Okay, there is some error I can see. It has divided, but there is some error. But in this case, most of the values are divided here, right? But here in this case, you can see, right, the accuracy will be more. Okay, we'll be calculating accuracy here, we'll be calculating the error value because it is the regression case, this is the classification case. Okay, so when there are any so even in case of test data, when we are dealing with the test data, there might be some issue with the test data. Okay, so we may have the overfitting condition here also. So when choosing training data, test data, there are some values that we have to follow to keep the data, okay, the data set balanced. Okay, so we split the data randomly, and we see that my training data has 60% data and validation has 20% and testing has 20%. And in case of training and testing, we are taking only two data sets here. 80% of data will be in training and 20% will be in testing. Okay. So these are few things that we take care when we split our data. Uh, so these are few details that are related to CRISP MLQ. Okay, CRISP MLQ. So we have seen applications. Okay, we have seen applications of data analytics in oil and gas industry. We have covered the CRISP MLQ methodology because when we are dealing with data analytics, we have to work with the project management methodology, and here in this case we have CRISP MLQ. So we have understood what is CRISP MLQ and what are the different methods we have and all. Okay, and tomorrow we are going to look into data pre-processing and EDA techniques. Okay, we are going to work on these techniques tomorrow, and then we'll proceed with different machine learning models, both unsupervised as well as supervised techniques. Okay, friends. Thank you for today's session. Let us meet tomorrow on uh, the domain analytics program that we are dealing with oil and gas analytics. Yeah. Thank you, friends. Thank you for the day.